What's going on, guys? Today we're going to talk about UPC codes and how they work. We're going to create this little device here. It's got an e-ink paper display. It's battery powered, fits in your pocket. Connect to it over Wi-Fi using your mobile phone, and you can generate any UPC code that you want. And we're going to test it all out with our trusty barcode scanner here after we talk a little bit about how UPC codes work. So let's get started. So we're going to take a look at the UPC-A barcode because it's the most commonly used barcode for products in North America. There are 6 left-hand side digits and 6 right-hand side digits, so 12 digits in total. And this last 12th digit is the check digit, and it's basically like a checksum using the first 11 digits to calculate it. And in every barcode, there's the end, the middle, and the start guard patterns that are always the same in the barcodes. All of the symbols of the barcode are made up of equal width columns, and it's just which ones are black and which ones are white that dictate what symbol it is. So if we take a look at the middle guard pattern here, you can see the width of the columns because for the middle guard pattern, it just alternates between white, black, white, black, white. All of the symbols for the right hand digits and all the symbols for the left hand digits all use these equal width columns, and it just depends which ones are black and which ones are white to determine which symbol that we're going to be encoding or decoding. So the start and end guard patterns are the exact same. And you'll notice that the left-hand side symbols, so if we take a look at 0 here, it's made up of 3 white columns, 2 black columns, a white column, and then a black column. And if you take a look at the right-hand side one, it's the exact opposite. So I'll zoom out again. You'll see that there were 3 white columns to start here. Well, on this right-hand side, there are 3 black columns. And then on the left-hand side here, there are 2 black columns here. Well, now there's 2 white columns, and so on. So the left-hand side and the right-hand side are just inverted colors. And the reason that they have that is so that when the scanner scans a barcode upside down, it will still know the correct sequence of all of the digits. So we can see all of the different symbols here for 0 through 9 for the left-hand side and 0 through 9 for the right-hand side. And basically, once we know the symbols for the left-hand side, we know already basically how to draw the right-hand side ones because they're just the inverse of the left-hand side. So now that we know how to generate our own UPC-A barcodes, let's take a look at the last digit here, the 12th digit, and how to generate that check digit. So if we take a look at the Wikipedia page for universal product codes here, we see the check digit calculation section, and it basically explains how to calculate the check digit, which is going to be the last digit in our barcode here, number 12. And basically, you just have to satisfy this equation so that you get a 0 here at the end. And all of these subscripts, 1, 2, 3, etc., are just the digits in your barcode. And there's a really good example here of how to do this one. Basically, you don't know the 12th digit, so that's what you're going to calculate based on the first 11 digits here. And basically, you sum up the odd number digits, multiply the result by 3, add the even number digits, you get that result. You find the result of that, and you modulus 10 it, mod 10, and you're left with a number. If that number is not 0, you subtract m from 10, and you will get your final number. So for this example here, we can see that the check digit is 2. I'll leave it up to you, but you can work through this and convince yourself that this is true, and check other barcodes that you have lying around, and they will all have this same way of calculating the last check digit on the end. Once we can calculate our check digit, then we can basically generate any barcode that we want and change the first 11 digits to whatever we want. So I've created a website here, and I'll show you that, and we'll generate our own barcode based on the first 11 digits. When I first started playing around with barcodes, I created this little simple website. It generates barcodes using JS Barcode, a JavaScript library. And then it has some extra JavaScript that's running in the background that as you type into this text box, it makes sure that everything's going to work out in the end, and that you have the correct number of digits in there, because it will calculate the check digit for you. So I have a Mastercraft drill and driving set in front of me right now, and I'm just going to go ahead and type the first 11 digits in, and the website will calculate the check digit for me. So as soon as there's enough digits in here, 11 digits, we get a message. That should work. We hit generate, and I know that this check digit here is 7, so we'll just see if it calculates it properly, and it does. So basically, JS Barcode requires that the check digit matches and is going to be correct before it will generate a barcode. So basically, this JavaScript takes care of that for me, and I only have to worry about the first 11. This website's really great because when I first started playing around with barcodes, I wanted to be able to print them on the fly and have the first 11 digits, whatever I wanted them to be, and print them out. So this Perry Page printer here, you can get it on AliExpress, and it comes with this roll of sticky paper, basically, and you can connect to the Perry Page over Bluetooth and basically send that image that we saw earlier that the JS Barcode library generated for us, and we can print them out directly on printer paper. Otherwise, you can use this LilyGo T5 here, and it's the 2.13 inch e-paper display with an ESP32, and it also has this little charging circuit on board, so you can plug in a little tiny battery. And the one that I'm using is a 150 milliamp 3.7 volt battery, and it comes with the connector here, so that when you buy a little battery there, you can just solder up the connector. It'll plug into here, and whenever you have USB plugged in with the USB micro, it will charge the battery for you. It also has an ESP32 on board with a Wi-Fi antenna here on the side, and of course the e-paper display on the other side. So you can run your own code, and just like the website I showed you before, you can run your own version of that and generate your barcode using the first 11 digits and have the ESP32 calculate the check digit for you. So we can take a look at that on the bench, and I'll show you how it all works. So we've got our trusty barcode scanner here. I have a Mastercraft drill and driving set we're going to use as an example. Here's our barcode here. We have the T5 Lily. It can be powered by a battery if you want. It's actually getting charged right now because it's plugged in. And we're connected over Wi-Fi to the website that's being hosted off of the ESP32 on the T5 here. And I've already typed in the barcode here, leaving off the last digit because it's the checksum, and we're going to get the app to generate the checksum for us. So let's go ahead and hit submit here. And when I do that, you're going to see this screen update, and it'll generate the new barcode for us. So I have Notepad++ open here. We'll scan the Mastercraft first. You can see the barcode there, and we'll try out the T5. And you can see we get the same barcode. So what we can do now though is change the barcode to whatever we want. And let's put a 4 in there and see how that goes. And we'll hit submit. We'll get our new barcode. And now we should see a barcode with 514 on the end and the correct checksum. And we do. So I hope you like this video. Like, share, and subscribe. Don't do anything illegal. Don't do anything stupid. And I'll catch you next time.